C and C++ provide unary operators for incrementing and decrementing values. Sometimes these operators are called increase and decrease operators, and they increment or decrement a value by 1. Let's take a look at how this works. We'll make a working copy of working.cpp out of the Chapter 6 folder in your exercise files. I'm going to paste this into our working project and double-click on it to open it up. I'm going to start by creating an integer, I, and we'll give it a value, 12. And we'll go ahead and print out that value. I'm going to use printf for this because it's a little more convenient. So we'll save that and compile and run it. When you get this, you can sometimes just say always run in background. I just click on the button there. It just happens sometimes. It may or may not happen on your screen. It's nothing to worry about. So it says here that the value is 12. And so now if I increment the value, I'm just going to come down here on the next line and I'm going to say ++I semicolon. And so what that does is it increments the value. Now when we print it out, it'll say value is 13. So I'll save this and run it. And it says value is 13. Now the beauty of the increment operator as opposed to just assigning a new value, if I were to say I equals I plus 1, that's really two separate operations. It performs this addition, and then it copies that value and assigns it into I. So obviously a compiler will probably optimize that down, and it may not actually make any difference in clock cycles, but it is more complicated, and it is semantically doing a different thing. The increment operator is incrementing that variable in place. But the real beauty of this is that I can increment and print it all in one operation. This actually returns that incremented value. So if I do this, I'll get the value is 13. Save and run. It says the value is 13. And if I do 3 of these, I'll get 13, 14, and 15. Save and run. 13, 14, and 15. There's another interesting aspect to this, which is that I can put the ++ after the I, and instead of incrementing it first, it'll increment it after it returns the value. So if I save this and run this, I'll get 12, 13, and 14. So what this is doing is it's actually returning the value first and then incrementing it. So it returns the value, which is 12, and then it increments it, now it's 13. And then in the next printf, it returns the value, which is 13, and then it increments it to 14. And on and on and on. So this is called prefix and postfix versions of the increment operator. In the prefix version, increments the value and then returns the value. In the postfix version, it returns the value and then increments the value. Very simple, very intuitive, and very useful. Of course, this also works on floating point values. So if I define this as float, we now have a floating value, so I'll change these to float, and we should get 12.0 and 13.0 and like that. I'll save that and run it. And interestingly, it also works with pointers. Now, this is a little bit more involved, but it's tremendously useful and it's actually used a lot. So let's take a look at how this works. So I'm going to declare a character array, S1 equals string. And that creates a character array with 7 elements, the 6 letters, and a null. And I'm going to create a character pointer and assign it to the beginning of the string. Now I'm going to print this out, dereference the pointer so that we can see that it's actually pointing at the first letter in the array. So that is the letter S. So we'll save that and run it. And it says value is S. So again, what we have here is we have an array of characters. The first element is an S, the second element is a T, the third element is an R, and so on. And a character pointer that's initialized to the beginning of the array. And here this *C that dereferences the pointer, and it gives us the value that's being pointed at, which is a character C. Now, the beauty of this is that because pointers are strongly typed in C, when I go and increment that, I'll just do a postfix increment first, and we'll make a few copies of that, it will print the S, the T, and the R. And so we'll save that and we'll run it. That's the S, the T, and the R. So what we're doing here is we're incrementing the pointer and then dereferencing it. So that seems really obvious and it seems really straightforward. Here's where it gets interesting. If instead of a character array, I make this an integer array, and we'll call this I1, and we'll initialize it to 1, 2, 3, 4, and 5. And then we'll make an integer pointer, and we'll initialize that to the beginning of the integer array. And then these are going to dereference integers. So we use %d and IP for the integer pointer, and we'll do 3 of them just like that. So now what we have here is we have an integer array with 5 elements, and they have integer values in them, 1, 2, 3, 4, and 5. We have an integer pointer, IP, which is initialized to point at the beginning of the integer array. So it's pointing at that first element, which is the 1. And we're incrementing that pointer and printing out each of the values. Now here's the interesting thing. An integer is 4 bytes. When we were doing this with characters, each time we incremented the pointer, it would increment by 1 byte in the array to the next element of the array. Here, these elements in the array are actually farther apart. They're 4 bytes apart rather than 1 byte apart. But the beauty is because the pointer is strongly typed, it knows that when you use the increment operator, it's going to increment not by 1 byte, but by the size of the object that it's pointing to, in this case, 4 bytes. So we will actually get 1, 2, and 3, just like we would expect. But the important thing to remember is that it's actually incrementing differently. It's incrementing by the size of the object that it points to, and it knows that size because the pointer itself is typed to point at an integer. So I'm going to run this, and we'll see that we get the result that we expect, 1, 2, and 3. And just like with the integers, we can use postfix or prefix increments and get exactly the same result. Here it has 2, 3, and 4 because it's incrementing before it's taking the value. So this usage is actually very common. You'll commonly see something like this. And I'm going to terminate this with a 0 because that's the common pattern for that. So you'll commonly see patterns like this, where we have initialized a pointer to point at the beginning of the array, and we're going to loop through while there's still a value being pointed at, and we're going to increment that pointer. And you can use this for any type of an object, as long as you have a terminator that you can test for. In this case, it'll print out 1, 2, 3, 4, and 5. And because these pointers are strongly typed, you're able to just use the increment operator like this and let the pointer worry about how far to increment. So the unary, increment, and decrement operators are very useful and very common. Keep in mind that the prefix version increments before returning the value, and the postfix version increments after returning the value. Now let's delete our working file and run clean to get set up for the next lesson.